Aloha everybody again. All right, so this is our extra practice video, and in here, please follow the instructions. So after I read the instructions, then you'll pause your video. You will download this file on Schoology, so it'll be a PDF in your Class A folder. And I'd like you to try these on for 15 minutes. Give yourself some time, and then whether you're going to be using Kami or if you want to print it and write on it, or if you just want to copy these problems into your notebook, either way is fine and awesome. And then this basically will be your solutions guide video for this. So give it a shot on your own. Come back when you have tried these problems, and then you will hear me talk about the solutions. So right now is the chance for you to pause. Pause the video, please. And we're going to assume that you have now just worked on this for 15 minutes. Yippee! So we're going to run through the solutions. So for all these problems, our mission is to write the equation of a line. And I want you to be comfortable with it in whatever form we give it to you. So the four forms that I gave it to you in this worksheet are in a table, in a graph, with points, or in some sort of like word problem scenario. And then at the end, I'll talk about domain and range. So if you didn't get to that, that's okay. We'll talk about it now. So for the first one, our mission is to write the equation of a line. Now what we've been using is the form y equals mx plus b. There are other forms out there, but this is the one that we are sticking with for now. When you're using the y equals mx plus b form, the things that we need to identify are the slope and the y-intercept, or at least the y-coordinate of the y-intercept. And these are the things that we're going to be looking for in all these ones. So first question here, they give us a table of data. And we don't know what the context is. I mean, this could be the height of a puppy, maybe it's the height of a plant, I don't know. But they started recording, and at 0 days, whatever the object was, it's got 12 inches in height. After 2 days later, it's 18 inches, 4, 24, 6, and 30. So the first thing that points out to me is this value right here is 0, 12. Well, 0, 12, after 0 days, this is when you're starting your data collection here. You got a height of 12 inches. Well, if it's the start of your data collection, that's the initial height of whatever this up. Well, we're going to say it's a puppy because my family wants to get a puppy. It's the height of this puppy. It's 12 inches off the ground. So this initial height is actually referring to the y-intercept, which means that my b value in this case is 12. So the y-intercept will always be 0, something, and that something, that y value of that y-intercept is always going to be that b value. So we kind of got lucky right off the bat. We were given a point. We got to figure out what the slope is. We're going to come back for the slope here. But we were given that the b value, the starting height of this puppy, is 12 inches tall. So now the only thing we got to find is the slope. And I mean, we're given that it's a line, so we should have a slope. We should have a constant rate of change. So let's see if we can identify it. I'm going to switch over to black here. So as the days go up, ooh, they're not going up by 1. They're actually going up by 2, aren't they? The days are always going up by 2, by 2, by 2, by 2, by 2. And what is the height going up by? From 12 to 18. So if you want to find, you're looking for that difference. The difference in height is 6. And if you go up here, it's another 6. And you go up here, it's another 6. So the slope in our problem is always, so I'm going to rewrite this the long way again, just so you can review it. It's rise over run. And rise is a correlation, is a change in the y values. So we're looking at the change in y's versus the change in x's. So if you wanted to call this on point 1 and point 2, you can do that. It would look something like, so we already calculated this in our head, but we're going to write it out kind of the long way. So like if I call this point 1 and this is point 2, this is our x, this is our y, it would look like 18 minus 12 all over 2 minus 0. And this is your 6 over your 2. And that's the values that we're looking for. As the days increases by 2, the days is on the bottom. That's your x. The height, the y, increases by 6. And you can actually reduce that. 6 divided by 2, that's the same thing as like 3 over 1, or just 3. So this is referring to how many inches it grows in 1 day, right? If it grows 6 inches in 2 days, that means it's growing 3 inches in 1 day. So if you wanted to sneak another point in here, you could say like this would be 1 and 15, and that would fit that pattern. Up by 3, up by 3, up by 1, up by 1. So this would be our equation. So if you got a table, you can do it like that. Another thing you can do is you can always just draw it on the graph. At 0, you're at 12, and then at 1, you're at, or at 2, you're at 18. And you can see that this is a positive semi-steep slope. All right, so number 2. So write the equation of the line given a graph. Okay, well, we can do this. In order to do this, we are going to be looking for y equals mx plus b. So the things that we are looking for are is the slope and the y-intercept. Well, again, I gave it to you really nice. The y-intercept is 0, negative 4. So where it crosses the y-axis here, this is our y-axis, that's our x-axis, where it crosses the y-axis is at negative 4. So we kind of already have a really nice start to this. Will this be enough room? We'll find out. We just got to figure out what the slope is. But I know that the b value is negative 4, crosses the y-axis down there, negative 4. So now we're going to find our slope. Well, for here, again, we can use the rise over the run. I'm going to switch back to blue. I'm just kind of switching around here. From this point to that point, we're going to go up 1, 2, 3, 4, 5, 6, and then over 1, 2, 3, and over 3. So my slope is, my rise is 6, my run is 3, and 6 over 3 is 2. So we could have noticed that also, like right here's another really good point. Up 2 over 1, up 2 over 1, up 2 over 1. So whether you're going up 6 over 3 or up 2 over 1, you're always going to be landing on another point that's on that line. So there is the equation of the line given a graph, how you can find it. So the next one, so we kind of, this is like a combination of both of those, with the exception of we're not given a y-intercept anymore. So now we're going to have to find that. So for this one, we'll go back to black here. So I am just going to call these 0.1, I'm going to call this one 0.2. So again, what we're going to need is to find the slope and the y-intercept. So I, again, like to start with just a graph. So negative 1, 4 is roughly right there, and 1, negative 2 is roughly right there. So our line is going to come through and hit somewhere in there, right? So somewhere in there was where our line is going to be. That's where our b value is going to be. So if you're given 2 points, well, really the only thing you can do is find the slope between them. So again, it's y2 minus y1. So if you need to write it out every single time to try to get it into your hand memory, I think that's a really good idea, over x2 minus x1. So it's the rise, which is the change in y's, how far up or down do I go? So this one's negative for sure, versus your run, how far over do I go? So my y2 is negative 2, subtract my y1, which is 4, all over my x2, subtract my x1. Negative 2 minus 4 is negative 6, and 1 minus a negative 1 is the same thing as like 1 plus 1, which is 2. In this case, look at that, a slope of negative 3. And that seems to fit the bill if I were to draw a line accurately through there. It's a very steep negative slope. So now we have to figure out where it crosses that. So what we're going to do here is pick one of these points. Doesn't matter which one you pick. I like to pick smaller numbers, so I'm going to pick that one right there. So I'm going to take this. This is my, let me delete this for a second here. This is my x and my y, and we're going to plug it into this equation, filling in values for the y, the m, which we found, in the x, and then the only thing we'll be left to find is the b. So here's your quick refresher on that. So y, which is negative 2, equals m, which is negative 3, times x, which is 1 in this case, plus b. Well, negative 3 times 1 is negative 3. And then now I can get b alone by just adding that 3, because adding that 3 will be the inverse. This will cancel out to be a 0, reduced to be a 0. And negative 2 plus 3 is 1. So that means our b value, where it crosses the y-axis, is at 1. And that's it. We got everything that we need. Let me find a color here. So what we needed was our slope, which we found to be -3, and our y-intercept, where it crosses the y-axis, was at 1. So this should be your equation for that line. Last one for writing an equation line that represents the following. So here we just got a funky scenario. My kids were playing with Legos the other day. And I do not have a kid named Ron. I have 2 girls. But anyways, Ron currently has 105 Legos put in place. So I don't know what he's building. Maybe it's a spaceship. I don't know. For his new Lego set that he got. How exciting. And he noticed that he can put about 15 pieces per minute in as he's building. So our mission is to write an equation line that kind of models that scenario. So we're looking for y equals mx plus b. There we go. So the things that we have to identify are the slope and the y-intercept. Okay, well, in this scenario, the slope, that's your rate of change. How are things changing, and by what unit, I guess. So in this case, it's given to us right here. He can put in 15 pieces per minute. That's your rate of change. So your rate of change for this is 15. And the next one is the b value. Well, that's your starting amount. That's your initial amount. How much did we start with when we were doing this activity? Well, he already had 105 pieces put in place. So in this problem, the x is acting as the time, how many minutes go by, and the y is acting as how many Legos he has in place. You tell me how many minutes have gone by, I tell you how many Legos he has in place. And the slope is representing how many pieces he can put in per minute. Okay, so give yourself a little formative check. How many of those 4 did you get right? And if you have any questions, make sure you mark them and ask me. Otherwise, we're going to move on to the one last thing. So this is going to be helpful for our second activity, is just recalling domain and range. So I just kind of wanted you to fill in the table with the other names for domain and range. For example, domain is the x values, and we also call those the input. And then you might have got stuck here. What I have written in my notes before is domain, since it's the x-axis, we always go from low to high, and on the x-axis, it's always left to right. The range, flippy-floppy, is the y values, which are the outputs. And for the range, the y-axis, that runs up and down, but if you want to say it from low to high, you would say from down to up. How low does my graph go? And then I also want to give you a sneak peek at Desmos, because we're going to be doing an activity in Desmos. So if I can bring this into my view here, a little bit further, there we go. What I want to do is I'm going to be restricting my domain. So I don't know, I'm just going to make some stuff up here. 3, sure. So if you want to restrict your domain in Desmos, you can type your equation out, whatever it is, y equals -1/2 x plus 3, and then at the end you can use a little curly bracket. So the curly brackets are above the square bracket, so you have to hit shift square bracket. And then we can restrict our domain. So the domain focuses on the x values. So if you wanted to restrict our x values, suppose we only wanted to look at all the x values from 1 to 3, right? So on that line, you can close it off there. On that line, we're only going to get values that are on that line, -1/2 x plus 3, from the x value at 0 all the way up to 3. And if you want, you can compare what that line looked like before. And if you want to be really fancy, you can click over here and you can make it, I don't know, dotted or something. So that way you can see that the black line is just that piece is from 1 to 3. And you can do the same thing, let's see here, 1/2 x, we'll just keep it like that. If you want to restrict your range, well, the range is the y value. Suppose I want to do everything from -2 all the way up to, I don't know, 4. Well, I could plug that in by doing -2 less than now y, because that's my domain, or I'm sorry, my range. less than, what did it say, 4 about? So now this is a chunk of line that when you look at the y-axis, which is going up and down, the lowest y value you see is -2, and the highest y value you see is 4. So if you want to restrict your domain or your range, you can put these curly brackets with the inequalities in there. And if you want to just keep x bigger than 0, you can just have it one-sided as well. And some people find that weird written like that, so you can switch around like this. You can say like x has to be bigger than 0, so it's going to get everything there. Or suppose you wanted at -2 for the x-axis. Great. Wow. All right, so that should get us started. We will come back in class, and we will continue on from then. Thanks a lot, guys.